Hello everyone, and welcome back to another remote sensing lecture video. And in this video, I want to continue our discussion on how do we select imagery. And I want to continue going through the questions that I would work through personally whenever I'm trying to figure out what type of imagery to use for a given application. And to sort of pick up where we left off, right, we talked about what is the purpose of the image. Are we trying to classify something where we need to be able to access pixel values and alter data? In which case we would most likely have to go find an image, download it, and curate it ourselves. Versus, are we simply trying to give visual context or digitize, which means to literally trace something off of an image? And in that case, we could use a pre-generated data set like Google Earth or the Esri base maps. So the next question, once you kind of figure out what the purpose of the image is you start to have to think about what are you actually trying to identify, right? What type of thing what types of things are you trying to see, to identify? Right, and this comes sort of with two sub-questions. Right, what's the smallest thing? You want to identify? I'm going to slide down a little bit so we have a little more room to work with here. All right, what's the smallest thing you're trying to identify? I'm going to give ourselves a little bit of space here. And then sort of related to that is what are the features of what you want to identify? Okay. And so I want to talk about these two questions sort of together because they're related. All right, what is the smallest thing you want to identify? And what I mean by that is literally what is the size of the thing that you're trying to find in the image that you're most concerned about? Okay, so let's take an example of vegetation. Right, I really want to find vegetation. And that can mean a lot of things. Right? So, for example, are you interested in identifying individual trees? Because that's going to mean something very different than I want to find large patches of forest, right? They're both vegetation, but one is at a very small scale, right? Individual trees versus large acres of forest. And so, as a general rule, when we talk about the smallest thing we want to identify, and this is a term that I think you should sort of commit to memory, what we're talking about is the minimum mapping unit, or the MMU. Right, and this is the smallest object you want to identify. Okay, and so the key thing here is your minimum mapping unit. This should tie directly into your spatial resolution. Right, so you want, so I'm going to put this in all caps, right? You want spatial resolution to be between 1/4 and 1/2 the MMU. U or less, right? Between 1/2 and 1/4 the MMU or less. So let's go back into ArcGIS Pro for a second and talk about what I mean here. So I'm going to go back into Planet. I'm going to make it not be false color. So we're going to go 3, 2, 1. Okay. So I'm going to turn off the base map here for a second. Let's say that the thing that we were most interested in trying to map was vegetation, right? And we wanted to map individual trees. We wanted to put a point on every single tree on Farmingdale State College's campus, right? So we can go here. Right? This is Farmingdale State part of Farmingdale State College campus, right? And if we wanted to put a dot on every single tree on campus, this is something that you might actually want to do. Say you're trying to do a tree count, and rather than walking around campus, you want to just sit here. You just want to put a dot at every single tree crown on campus. Right. Something like orthoimagery, which has a spatial resolution of 1/2 foot, right? That's doable, right? I can see tree, 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 right? Totally doable. But let's say that you wanted to do that same thing with Landsat imagery. So I'm going to turn that off. It's impossible. You have no way of knowing where the individual trees are. So that's where that minimum mapping unit comes in, right? What size thing are you trying to identify, and how does that relate to the spatial resolution of the imagery? So that's one good example. Another example might be roads. Let's say you were trying to map the highways, right, the roadways on Long Island. Right, this Planet image, right, you can clearly see the roadways, right? You can clearly see the roadways. Again, if we transfer over to Landsat, right, you can see some of the roadways, but you can't see other roadways. So again, in this case, Planet might be the better choice here because you can delineate the roadways much easier. Now let's say instead you wanted to map every single forested area that was larger than, say, 100 acres. Right? In that case, Planet and orthoimage might be impractical because they would just be there'd be so much data. Right? If we turn off Landsat, if we wanted to do the entirety of Long Island, right? The entirety of Long Island, and we wanted to map every single forested area that was larger than 100 acres, right? Planet could do the job for sure, but it might be impractical because it's just the pixels are so small. They're unnecessarily small. So when you're trying to map something on that large of a scale, right, you might end up wanting to go with something like Landsat because 100 acres is clearly going to be bigger than the spatial resolution of Landsat, and the aerial coverage, right, the total coverage of a Landsat scene is far more appropriate to get the entirety of Long Island. So hopefully that makes sense. So that's this, right? What's the smallest thing you want to do, the minimum mapping unit, and how that ties into the spatial resolution of the image that you're trying to choose. And then sort of along with that, right, what are the features you want to identify? And what I mean by that is, do they have special characteristics? Right. So for example, are you trying to map a plant that blooms a very distinctive color in August, and then for the entire rest of the year, it looks just like all the other vegetation around it? Right? You would want to pick an image or an imagery or a data set that gets imagery in August because that's when you're most likely to be able to identify the thing that you're looking for. So sort of wrap this one up kind of quickly, right? Do these features have special characteristics, and how can we maximize those characteristics? With imagery. Another good example would be if you're trying to map lava flows, right? You could certainly get away with mapping lava flows in a true color image, but you would probably have a much better time of it if you used imagery that collected in the thermal region, because that lava is going to be emanating a lot of heat, which would be detectable in the thermal region, right? And that's a special characteristic of lava, right? Lava is substantially hotter than the surrounding environment. Right? So again, right, do these features have special characteristics, right? Are they hotter than their surrounding environment? Is there a particular time of year where they're particularly colorful? Is there a time of year where they're particularly distinct in some other way? Right? And then how do we take those special characteristics and maximize them in the imagery? Hopefully that made sense. If any of this didn't, I encourage you to go back, rewatch the parts you're confused about. And as always, please reach out. Thank you.